Hey guys, hope you're having a great day. Today we're going to be going over 1.3 combining and evaluating functions. So what we're going to be doing is adding, subtracting, multiplying, and doing division for functions, two or more functions. Now, hopefully the adding, subtracting, and multiplying seem like review. What's going to be somewhat new is the division, specifically because we're also going to identify some restrictions, because in a fraction, division being fraction, right? You cannot have 0 in the denominator because we can't take anything and divide it by nothing. It doesn't work. And plus we're going to evaluate a function using a specific substitution. In the past, we have focused on just a number, right, f of 5, and then evaluating that way. So we're going to do a little bit of a combination of new and old stuff. Okay, so we have a little cheat sheet almost that you can refer back to. So when you do addition, there are two ways that you could see how we can add or see when they want you to add the two functions. So you can see it where it says f plus g and then of x, or you could see f of x plus g of x. Okay, either one of these means you're just going to add the two equations together. And we know from 1.1 that when we add, we're just combining like terms. For subtraction, it could look f minus g of x or f of x minus g of x. We know from 1.1 that we would distribute that negative out and then combine like terms. Multiplication, same way. These are the two ways that you could see the multiplication set up. But really, remember, all we're doing is the box method or distributing like in 1.1. Now with division, of course, this is how you would see division. Now, either we are just going to put it in this form and look for restrictions because you can't simplify it, or in some cases, especially in further chapters, we are actually going to factor and see if there's anything that we can cross out, then look at the restrictions. Okay, so here's an example, and I'm going to try to go through this quickly so you guys can just see. What's going to happen is when we combine functions, more than likely, we will give you multiple functions up at the beginning of the page. Then you might see something like this. This, of course, tells you, hey, I'm going to take these two functions and add them together. Actually, right now, I'm going to change markers because that green's a little dark. So let's see if I can do maybe the orange. So we're going to say f plus g. So I'm going to take the f of x function right there, and then I'm adding the g of x, right? And then we just do what we did in 1.1. Subtraction, make sure you look at the order for this. This is f and then minus g. So again, here's the f of x function. Here's the g of x function. We're subtracting them. Next one, multiplication. We would take our f of x in parentheses and our g of x in parentheses, and then of course either distribute or do or box. Now this is a new one, right? So I'm going to take my f of x over my g of x. Now, of course, in the future, what we're going to see is, hey, can we simplify it and cross anything out? But right now, I'm going to tell you there's nothing to cross out. So now when it comes to domain restrictions, again, only for division, what we're going to do is we're going to take the denominator, and set it not equal to 0. And then we're going to solve. So of course, here they have this x plus 7 does not equal 0. And then we move that 7 over by subtracting. So we get that x cannot equal -7. And that is the domain restriction. All right, so let's try some of these out right now. All right, so we have, here's our f of x, here's our g of x. The first thing we're going to do is add them. So I'm going to take my f of x first, which is x squared plus 5x plus 1. And I'm going to add parentheses my g of x, which is negative 4x plus 6. We know with addition, all we have to do is go straight to combining like terms. So I like my strategy of doing shapes. There's no other x squareds. There's an x, there's an x, and then there is our constant. So I might go a little fast on some of these operations because we've practiced them already. So x squared, let's see, 5x and negative 4x is a positive x. And then 1 and 6 is 7. And we just added the two functions together. Next one, subtraction. Now, of course, remember, the order counts, so be careful because it won't always be f minus g. It could be g minus f. All right, so f first, so x squared minus 5x plus 1 minus, don't forget those parentheses, negative 4x plus 6. Now, remember, if you like the other way for the horizontal, like in 1.1, go for it. I'm just going to do it my way, okay? Which means I distribute first to that parentheses. So I have x squared minus 5x plus 1. That changes the sign, right? So that becomes plus 4x minus 6. Do my shapes. For combining like terms. So in this case, I have x squared, a negative 5. Oh, not negative 5 here. I made a mistake, didn't I? This was positive 5. Okay, sometimes that happens. 5x and 4x is 9x. And then positive 1 and negative 6 is negative 5. And we're done. Seems like 1.1, right? Okay. Now I have to go back and forth between memorizing the f and g functions. So let me look at my other page. All right, so this multiplication, so our f of x is x squared plus 5x plus 1. Remember, in parentheses, and we're multiplying that by negative 4x plus 6. Okay. I like doing my box. So negative 4. I like doing the binomial on the side. And the top one for the trinomial. All right, remember we multiply the little boxes in between. So don't forget, when you multiply, what do you do to the exponents? You add them. So negative 4x and x squared would be negative 4x cubed, right? Because we're adding the 1 and the 2. Negative 4x times 5x is a negative 20x squared. And negative 4x times 1 is negative 4x. We go down to the bottom row. 6 times x squared is 6x squared. 6 times 5x is 30x. 6 times 1 is 6. Look, the diagonals are like terms, sorry, are. Okay, so let me put this together. So that's negative 4x cubed. Let's see our x squareds here. We have negative 20 and 6, so that's negative 14x squared. 30 and negative 4 is a positive 26x. And then our constant of 6. And we just multiplied those two functions. Okay. D. This is the division, remember? So look at the order. It says f in the numerator, g in the denominator. So our f function was x squared plus 5x plus 1. and our g is negative 4x plus 6. And we cannot simplify at this point. I will tell you when we can simplify, okay? But what I do need to do is create a domain restriction. So this is my answer for division, but I need to add on what x cannot equal. So remember, what we do here is we take the denominator, which in this case is negative 4x plus 6, and we say it can't equal 0. And then we start solving. So negative 4x. Now, if I move that 6 over, I would be subtracting it. So 0 minus 6 is negative 6. And how do I get x by itself? I divide by negative 4. So I would get negative 6 over negative 4. But if we know our fractions, we know a negative over negative is a positive. And 6 over 4 can be reduced to 3 halves. Okay, so for this division of the two functions, you would need this part right here and the domain restriction. Because if x was 3 halves, we would end up with 0 in the denominator, and we can't divide by 0. What I would like you to do right now is take a moment and to do the first 2 questions on your 4-question sheet. All right, so hopefully you've done that, checked it off with me, and we're ready to go. Okay, so now what we're going to do first is we're going to remind each other of function notation. Okay, so naming that function and what to do. So this is f of x, just like g of x, right? This is function f, this is function g. So when I say f of 2, what just happened here? That x is gone, right? Now it's a 2. So that's exactly what we're going to do. In our function itself, we're going to replace every x with the value of 2. So in this case, instead of saying x squared, we're going to say 2 squared. Plus, instead of saying 3x, we're going to say 3 times 2. And then we have this minus 2 at the end. Now, for those of you especially using calculators, when you're replacing an x and that x has an exponent other than 1, you want to make sure it's in parentheses so the calculator does it correctly. Because if this were a negative number, which we'll see down below, you would get 2 different answers. So I'm going to do it without a calculator just to show you it's possible. 2 squared is 4. 3 times 2 is 6. So now if I calculate this all together, 4 plus 6 is 10. 10 minus 2 is 8. So f of 2 equals 8. Excuse me. We are evaluating f of x when x is 2. So down here, in this case, we're still using f of x, but in this case, we're going to say, hey, what happens when x is negative 3? So again, I'm going to write it out first so we see what we're doing. So negative 3 squared plus 3 times negative 3 minus 2. So we're going to do this without a calculator, and then I'm going to show you what happens on the calculator if you forget those parentheses, okay? Negative 3 squared is 9. 3 times negative 3 is a negative 9. Minus 2 at the very end, right? Well, 9 minus 9 is 0. Minus 2 is negative 2. Okay. I'm going to show you right now what happens on the calculator. As you can see, I'm going to prove to you that, oops, sorry. Me doing this in my head worked. Okay, so again, I got negative 2, the answer is negative 2. But watch what happens if I do not put those parentheses in for that squared value. We did not get -2. The reason why this happened is because in our calculator, the calculator took this as 3 squared, which is 9, times -1. So instead of saying -3 times -3, the calculator took it as 3 times 3 times -1. So be careful about those parentheses when you're using your calculator. All right, so earlier we had taken two functions and we combined them with adding, subtracting, multiplying, and dividing. Right now, what we're going to do is we are going to evaluate combinations. And I'm going to show you the best strategy for this. So right here, we have our two functions, f of x and g of x. Now we have f plus g, and then right here, this number tells us we're going to evaluate that at 5. So what we can do is we could take these two, add them together, so combine like terms, then plug in 5 for x and do what we did up here. But there's even a faster way. Remember at the beginning how we could write this as f of 5 plus g of 5. Okay, let me show you. Remember at the beginning, we went through this cheat sheet, right? This, right, is the same thing as this. Well, the reason why I like this way is because now all I have to do is evaluate f of 5, evaluate g of 5, and then add them together. So let me do that now. F of 5 tells me to replace x with 5. And here I get the value, let's see, 5 times 5 is 25, minus 2 is 23. Then I can do g of 5. So I look at my g of x here, and I replace all the x's with 5. So I get 5 squared minus 3 times 5 plus 6. Let's see, 25 minus 15 is 10. 10 plus 6 is 16. Check my work. Okay, you can do that in the calculator if you want. Now, what this is telling me is, hey, I'm going to add these two numbers together. I'm going to say 23 plus 16, which equals 39. And that is our answer to this f plus g of 5. Kind of easier than adding combining like terms and then plugging in the 5 for the x. Either way, you should come out with the same thing. Okay, let's do this again. Watch out, right? Because what happened here? Look at that order. It's g minus f. So if we were subtracting the two functions and then plugging in, we would really have to watch out. But I'm going to do the same strategy up here. So instead, I'm going to say g of -1 minus f of -1. These two things mean the same thing. So now on the side here, I'm going to say g of -1, plugging in -1 for x, right? So we get -1 squared minus 3 times -1 plus 6. Let's see. I'm going to do this in my head again. 1 plus 4 is 5. 5 plus 6 is 11. Again, check on your calculator if you need to. I just like doing things in my head just to exercise my brain. It keeps me young. F of -1 equals, make sure I get the right function. So this is 5 times -1 minus 2. That equals, see, that's -6. -6 minus 2 is -8. Now again, I'm going to make sure I'm in the correct order. So g of -1 is 11 minus f of -1 is -8. If you have to use a calculator, go for it. But 11 minus -8 would be 19. Remember all that work we did with multiplication? Well, if it's multiplication and evaluating, really stick with what we've been doing for A and B up here. So this would be f of 7 times g of 7. I might need my calculator for this, guys. F of 7, well, that would be 5 times 7 minus 2. So 35 minus 2 is 33. G of 7, oof, that square in there, huh? So I get 7 squared minus 3 times 7 plus 6. I am going to use a calculator this time just because I don't like to take your time up while I try to figure it out in my head. So 7 squared. Again, I don't need the parentheses there this time because it's positive, but I should get in the habit of that, right? Minus 3 times 7 plus 6. 34. And I definitely don't want to do my next one in my head because what am I doing with these two numbers? I'm multiplying them. So 33 times 34 equals 1,122. Sorry, I don't like when I write messy. Okay, and last one. Now, division, we had talked about before, putting one over the other and then finding the domain restriction. Well, that's because we had an x value there and we wanted to keep it in function notation. But now we're actually evaluating at -2. So we're going to do exactly what we did before for A, B, and C up here. So G is over F. So let's keep that in mind. So we're doing G of -2, which is -2 squared minus 3 times -2 plus 6. I'm going to do that in my calculator again, just to save you guys time. So I get 16. Okay, now let's do f of -2. So f of -2 would be 5 times -2 minus 2. I can do this in my head. 5 times -2 is -10. -10 minus 2 is -12. Okay, so let's remember the order again. It's G over F. So G over F. So 16 over -12. I can reduce that, right? Because 2 goes into 16 and 12. What else goes into 16 and 12? 4. So 4 goes into 16 4 times. 4 goes into 12 3 times, and it would stay a negative number. And there is G divided by F at -2. All right, do number 3 and 4 on your 4-question worksheet, and then get that checked off, and you can practice on your own.